Hello everyone, I'm Dirk from Team Codeblocks. Today I'll just be going through some architectural basics for our project this year. So basically Team Codeblocks decided to go with the microservices pattern. If you look at it at its most basic, basically what the microservices pattern does or is a small set or small number of independent processes that basically communicate with each other to form a larger system. For it to be considered a true microservices pattern, all these processes should be able to be deployed independently. And what this allows you to do is basically create a highly maintainable, highly flexible system that's also at the same time modifiable. Now, if you look at the overall architecture of a system, it can be broken down into four basic components. Basically the client, the API, gateway, microservices, and of course persistence. So basically, if you look at the client component, there are two basic entry points into the system, which is basically our Android app, and then there's the website. So the Android app would be used by the actual users to execute some of the commands for the system and the home automation etc. Then we look at the website, which would be used on our side for basic administrative purposes. So the API gateway has an important function within the system. What it does is it provides a single entry point to all the actual services hosted on the application server. So its primary goal is to identify specific IP addresses, and based off of these IP addresses, what it does is it determines to which local hardware, in other words the Raspberry Pi, needs to send its actual request to, so that we know that the command that has been issued is actually being executed on the correct device for the correct person. So what's cool about the whole API gateway is it allows you to implement some forms of security as well, since there's only one entry, or one, how would you say, entry point, or so basically the API gateway is wrapped with a RESTful layer, which it exposes its services to the actual client, respective clients on the system. Now if you look at the microservices component, as mentioned above, it's independent services that all function independently but can communicate to each other to form a larger system. So their purpose within this system is to perform a specific task within the system and do nothing else. So it's kind of like the Unix mentality, where you code one thing to do one thing properly. And yeah, so basically all these services are, as mentioned above, are logically separated. The API gateway therefore determines which of these microservices are to be executed by which device, depending on which IP address it has received. So a final component within the system is the persistence component, and it's basically all the persistence component does is it contains basic user information, so the system again knows which request is going where, which service has to be executed on which Pi etc. So, and that's all controlled by our side. Basically, to implement the microservices pattern, we've decided to go with the mean stack. What mean refers to is basically your MongoDB for persistence, you get your Express.js for the application server, AngularJS for front end, and then of course Node.js is the primary language. So the reason the main stack is such a logical choice for implementing such a system is because intrinsically it addresses issues of performance and scalability, which is rather important when attempting projects that have so many potential users that we hope to gain one day. If you look at Node.js by itself, it makes use of the V8 JavaScript engine for interpreting JavaScript code, and this provides us with a massive performance gain within the system. Also, since Node.js makes use of event-driven architecture, what this means is we can create scalable application servers without actually using threading. So intrinsically, it's also scalable as well. Now, for Mongo, on the MongoDB side of things, being a NoSQL database, it includes some forms of automatic sharding, or otherwise known as partitioning, which enables them to be scaled out on hardware, and this also intrinsically provides a massive scalability gain within the system. And the project is also aimed to address other quality requirements such as security, privacy, reliability, and flexibility. But all these are discussed further within the documentation should you want to view it at a later stage. And yeah, that's pretty much the basics from my side.